Suppose you have the following function, f of x equals to 2x plus 1. What will be the inverse of this function? And if you just look at it like a formula, yeah? No, not like that. So let's just think without any formulas. So if you have a function where it takes in a number, doubles it, and adds 1, what would be the inverse of that function? What kind of function would undo it?
-1 divided by 2.
Yes, perfect. So it's going to be you subtract 1 and then you divide by 2. That will be the inverse function. Okay. Okay, and then now comes the formula that you spoke of. So this would be like kind of obvious. Like if you want to undo some number where you doubled it and then added 1, if you want to undo that, you would first subtract 1, and then dividing by 2 will give you the previous number. So if you plugged in, say, f of 3 equals to 7, right? Then what do you get if you plug in 7 into this function? 7 minus 1 is 6. 6 divided by 2 is 3. So it's exactly the opposite. You can see that indeed, if you plug in 7 into this function, you get 3. See? The input was 3, output was 7. Now over here, input is 7 and output is 3. So input and output has been switched. That's what inverse functions do. But you're probably you'll probably need something more systematic than doing this, because in many cases the calculations of the function is much more complicated than this, so that it's really hard to just think through and build an inverse function. So let's do the following. I'm going to suggest 3 steps. Step 1, introduce y. And then step 2, switch x and y. Switch. And then step 3, solve for y. Let's see how those 3 steps will give us the same answer. So you start from f of x equals to 2x plus 1. And if I apply the step 1, it will be replace fx by y. So now I have, when I write like this, x would be the input of the function, y will be the output of the function. Is that good? Yeah. And because inverse functions switch input and output, the second step says you should switch input and output. So y becomes x, x becomes y. By doing this, we kind of enforce the role of the input and output to be interchanged. Yes?
This is, like you could do this, it does the same thing as the x minus 1 over 2.
Yeah, we'll see it. We'll see it. Yeah, you'll see that we get the same answer, okay? All right, so now you have step 3, which is you solve for y. So you subtract 1 both sides, and then divide it by 2. So this is what you get, and therefore f inverse of x is x minus 1 over 2. So this is more systematic. Okay. For easy ones, inverse functions are easy to figure out, but sometimes, in most cases, the functions are hard enough that you would need to follow these 3 steps to get to the answer. Okay, so given this example, let's do a few examples. And this, first you introduce y, right? And then you replace y by x, x by y. So 2y minus 1 cubed minus 3. Are we good so far?
Yeah.
How many of you got up to this point? Okay, several. That's great. Okay, so that's good. Now you're supposed to solve for y. That's what step 3 is saying. Solve for y, right? How do you solve for y? Well, you look at what's done to the y, and you just start undoing the last thing. I was talking about this socks and shoes analogy, right? Yeah. So do you take off your shoes first or socks first? Shoes, because that was worn last. Isn't that right? Yeah, yeah. Okay. So what you want to do is look at y. So you subtract 1, take the cube, times 2, and subtract 3. That's what happened, right? What should go away first? Minus 3 has to go away first, right? So what should you do? Add 3 both sides. How many of you did up till here? Why couldn't you get to this point? That's strange. People, I think those who couldn't go from here to there basically gave up thinking this is too hard. Okay, it's a mental thing. Yeah, yeah. It's not like you can't do it. It's just a mental obstacle there. Okay. All right. Now what has to go away?
The 2.
2 has to go away, right? Because that's multiplied last, so that should be divided. So we're going to divide both sides by 2, and that's going to give us x plus 3 over 2 equals to y minus 1 cubed. How many of you got up to here? Oh, less number of people. All right. Yeah. Okay, I thought up till here was kind of easy. Now here's the crucial part. Do you have to get rid of minus 1 first or cube first? Cube has to go away first. What gets rid of cube? Cube root, okay? So there are 2 ways to go about thinking about this. You could either take the 1/3 power, both sides, just like how we did in the last exam, right? Then 3 times 1/3, because they are reciprocals, they cancel each other, right? So if you do it this way, your answer will be in terms of 1/3 power, but 1/3 power is same as cube root, right? So there are 2 ways to write down the answer. You can write it as a 1/3 power, or you can also write it as a cube root. Either way will be given full credit. So on the right side, that's going to cancel away the the cube, and you just have y minus 1 equals to x plus 3 over 2, and there's a cube root here. Then what's the final step? You add 1, and that's your inverse function. So f inverse of x is going to be cube root of x plus 3 over 2 plus 1. Make sure this plus 1 is on the outside. Okay. How many of you got correct? Completely right.
I think I would have got it correct if I knew the answer to.
Oh, okay.
The answer had to be.
Yeah. There's no other way. You have to have a cube root or 1/3 power, either one. Yeah. Okay, let's try to apply. Let's do the next one. Okay. So you have y equals to 5 minus 1 over 7 minus x. Switch x and y, so you get x equals to 5 minus 1 over 7 minus y. And now you have to solve for y. Okay. Since there's this 5 I can move to the other side, let's subtract 5. So you have x minus 5 equals to negative 1 over 7 minus y. Now, at this point, you can do several different things. So some of you might just want to multiply negative to the other side. That's fine. Yeah, but I would rather multiply negative to the bottom and rewrite this as negative 7 plus y. That seems to be easier. Okay, so let's write it like that. X minus 5 equals to 1 over negative 7 plus y. It's perfectly fine to multiply negative to the other side and write down 5 minus x. The final solution might look slightly different, but they're equivalent. Okay. All right. So the problem is right here. You have this, and you have to somehow get rid of this 1 over thing. How do you do that? Well, the idea is to rewrite the left side as over 1, just like that. And then you take the reciprocal of both sides. Okay. You can take the reciprocal of the left, you can take the reciprocal of the right. Now, when you do this, you have to be a bit careful. So let me just give you some examples why we need to be careful. If you have 1/2 plus 1/3, that's 5 over 6. Now, if I take reciprocals of every one of these, is this true? No, it's not true, because 2 plus 3 is 5. It's not 6 over 5. No way. So that's not true. So that means you can't take reciprocal term by term. In fact, most operations you can't do term by term. That's illegal. The only thing that's allowed is when you multiply by a number or divide by a number. That's allowed for every term. You can multiply 7 to every one of them, and this equality will still be true. Okay, but that's about it. Anything else, those are illegal to be done term by term. However, if you apply an operation to both sides as a whole, then it will always be equal. So if I take this entire left side as something over 1, and I flip this over and make it as 1 over 1/2 plus 1/3, and you flip this side and make it as 6 over 5, you can verify that this is actually true. This is true. Yeah. In other words, the general principle is that if two sides are equal and you treat both sides equally and fairly, they'll still end up to be equal. You have a question? Yes.
How does 1/2 plus 1/3 equal 5?
Why this is equal to this? No.
When you reciprocate it.
Oh, no. The thing is, if I multiply 6 top and bottom, this is 6 over 6 times 1/2 is 3. 6 times 1/3 is 2, so it is equal to 6 over 5. Okay, yeah. It's not like this. This doesn't mean that you're flipping these separately. That will be doing it term by term. That's not what this is meaning. Okay. All right. So back to my point that if you have two sides that are equal and you treat both sides equally and fairly, then the outcome should be the same. It's just like when you have identical twins. You give them same food, they grow up in the same house, give them same toys, same clothes and everything, same school and all that. And then later when they grow up, you find that they both became doctors or something like that. Yeah. So if you treat them exactly the same way, the outcome should be exactly the same. That's how equal signs would happen. Okay. It's kind of obvious, right? So that principle is going to be applied here by saying, I have this left side and the right side. I'm just going to take the reciprocal of the left side and reciprocal of the right side. I'm treating both sides equally and fairly, right? So the equality will still be true. That means I have 1 over x minus 5 equals to negative 7 plus y. And now what would be the solution if I solve for y? Y would be 7 plus 1 over x minus 5, right? That's the answer. Or I really have to say f inverse of x is 7 plus 1 over x minus 5. Okay, that brings us to this last one. And I said this is much more challenging than the other ones. You'll see soon. So first we introduce y, that's step 1. 3 plus 5x, 4 minus 2x. Now in place of y, you put x. In place of x, you put y. Okay. And then you multiply 4 minus 2y both sides. X times 4 minus 2y equals to 3 plus 5y. That gives you 4x minus 2xy equals to 3 plus 5y. And now is the problem. How are you going to solve for y? You have more than one y, right? That's why it's challenging, right? So already you can see here, I mean, this is step 2, and step 3 says I have to solve for y, but I see a y here, I see a y there. If it appears twice, then it becomes really hard to solve. So even if I don't like fractions, that's why I multiply 4 minus 2y and expand it, I still see y and y. I have to have some ways to make these two y's to appear as 1. What do? You have to factor it, right? That was the idea that I showed before as well, right? So if you see y appearing twice, what you want to do is you want to put them together somehow. So I'm going to move the 3 to this side, you get 4x minus 3 equals to 5y plus 2xy. So that if you have y and y, you can factor the y out, right? So that gives you 4x minus 3 equals to 5 plus 2x times y. And now that allows you to divide and solve for y, because that factoring made the two different y's, two distinct y's, to appear as 1. Is that good? All right. All right. Let's continue over here a little bit. Therefore, if you divide by 5 plus 2x, you get y equals to 4x minus 3 over 5 plus 2x. And therefore, the answer is f inverse of x is 4x minus 3 over 5 plus 2x. Okay. All right, step 1, you introduce y. Step 2, you switch x and y. Now you have to start solving for y by subtracting 4 both sides. And then what has to go away first? The cube, because that's done last. If you think about it, you multiply by 2, subtract 1, and then cube is done last. What's done last must go away first. Shoes and socks. You need to get me when I say shoes and socks, right? Okay, now you take the cube root both sides to get rid of the cube, and you get 2y minus 1. And now you add 1 both sides. And then finally you divide everything by 2. Now make sure that your cube root just ends right here, and then 1 is added outside. It's not true that this plus 1 has to remain outside. It cannot be combined inside. Then you get something wrong. Okay. So you divide by 2, and therefore f inverse of x is equal to cube root of x minus 4 plus 1 over 2. That's the answer. Second question, you have y equals to 3 plus x over 1 plus 2x. Put x instead of y. Put y instead of x. Okay, let's get rid of the 3. So it's x minus 3 equals to y over 1 plus 2y. Oh, wait, but we have a problem. I see a y here, I see a y. So how do you solve in that case? Well, before we do anything, let's just get rid of the denominator. I don't like denominators, so x minus 3 times 1 plus 2y equals to y. You multiply this to the other side, right? And then you have to FOIL. So x times 1 is x. X times 2y is 2xy. Negative 3 times 1 is negative 3. Negative 3 times 2y is negative 6y equals to y. Why? What's the problem? Right. Okay, so now you
We all forgot our parentheses.
move that, so you have x minus 3 equals to y plus 6y minus 2xy. And of course, these two combine to give you 7y minus 2xy. Now what? What do we do? How do we make two different y's to be just one single y? You factor it out, yes. So you have x minus 3 equals to 7 minus 2x times y. And now you divide, that's your y. X minus 3 over 7 minus 2x. Therefore, f inverse of x equals to x minus 3 over 7 minus 2x.
Carl, I have a quick question.
Yes.
So on where it goes from x minus 3 equals 7y minus 2xy down to x minus 3, and then all of a sudden the 7 minus 2x is...
This is being divided both sides. Yeah. And then this side will cancel, and then you get that. Okay, let's ask the following question. You have f of x equals to x squared. What is f inverse of x? Now, it seems like a very easy question, a lot easier than the ones we started with, but there is some problem with this question because, for example, what is f of 3? That's 3 squared, which is 9. Okay. What's f of negative 3? 9 as well, because if you square a negative 3, negative becomes positive, so you get a 9 as well. So in both cases, you get positive 9. That means if you ask what's f inverse of 9, you don't know if this should be 3 or negative 3. Right? You have the following problem. And this makes it impossible to construct an inverse function. In fact, because of this very reason, f inverse of x for x squared doesn't exist. Now, often when people ask me what's an inverse function, I try to explain using factories because functions are like factories. It has an input, and you get some raw material, and the factory does something, and now comes the output, right? So imagine a factory where it takes chickens in, and it gives you back chicken nuggets. That's a function where the input is chicken, output is chicken nuggets, right? Now, what's an inverse factory? Or what's the inverse function of this? It would take in chicken nuggets, and out comes chickens, right? That's an inverse function. Okay. It's not possible with the current technology, of course, but hypothetically, if we have the analogy, that's what we have. Okay. So
you're saying
no, not that. Okay. All right. So that's like a function. But now here's a situation. Imagine that in the world there are just two kinds of chickens, red chickens and blue chickens. Just hypothetically. Yeah. I know that there aren't red or blue chickens, but let's say there are red chickens and blue chickens. Now you feed them into this factory. The factory doesn't care if it's red or blue. Out comes chicken nuggets. Beautiful, right? Now the problem is if you try to build this inverse factory, what happens? You feed in chicken nuggets, and people don't know whether to produce blue chickens or red chickens. There's no way to tell, right? That's the problem. That's why even if you say the technology is so advanced that you can make chickens out of chicken nuggets, this still will be theoretically impossible to build an inverse factory just because it's logically impossible. You see what I'm saying? Okay. So in other words, in this story, my point is that if you have two different inputs giving you the same thing, if two red chicken and blue chicken both gives you 9, then there's no way to invert it because you don't know which one to produce. Right? Now, graph-wise, this is what happens. Graph-wise, here's 3, here's negative 3, and the graph of y equals x squared is this one, right? F of x equals x squared is a parabola so that they both give you this value 9. Therefore, what happens is that if you draw a horizontal line going through 9, it's going to meet at x equals to -3 and x equals to 3. And that immediately gives you this motivation for a test called HLT, or horizontal line test, which says if a line meets the graph, oh, sorry, it's not just a line, it's a horizontal line. Let me start over. If any horizontal line meets the graph more than once, the function is not invertible. In other words, i.e., f inverse of x does not exist. That's the horizontal line test, okay? All right, so let me move on quickly to restricting the domain idea. And here's the idea. So let's say some king really wanted this inverse chicken nugget factory to exist. So what he does is he decrees to the whole kingdom that no red chicken shall be cooked to be made chicken nuggets. Okay? Now, if this is decreed, suddenly what happens? Theoretically, it's possible to build the inverse factory, because now when chicken nuggets is fed in, you know that it wasn't red chickens to make this chicken nuggets, so blue chickens are produced. The scientists are happy, the king is happy, everyone's good, okay? All right, so that's the idea. So the way you can make a non-invertible function which doesn't pass the horizontal line test to actually pass the test is to restrict the domain. You say, we're not going to allow this one. Negatives? No. Just do that. No. Okay. So, in other words, we're going to change the question. The new changed question is, so now the new question is, if f of x is x squared with x is 0 or positive, okay, you don't allow negatives, okay? Then what is f inverse of x? Now, that graph will perfectly pass the horizontal line test because you only have the graph from 0 to positive. You only have the right portion. So any horizontal line you draw, there is no horizontal line that would meet with the graph twice or more. Okay? If it does meet, it meets once. It might not meet, that's fine. Okay? So this passes the horizontal line test. Therefore, you will be able to find the inverse function. I forgot to add that if it does pass the horizontal line test, then the f inverse does exist. Okay? So how do we get it? Well, we get it the same way, almost the same way as how we found the inverse functions before. What was step 1? What's step 1? Introduce y, so y is equal to x squared. Step 2, swap y and x. Okay, but here's a catch. The difference is you can't just say y equals x squared. You also have to write down the inequality as well. This inequality should be present. And when we swap x and y, it means that anytime we see a y, we have to put x. Anytime we see an x, we have to put y. So you have x equals y squared. But what about this one? You also have to say y is greater or equal to 0. That's what you have to say. Okay. This x, because we swapped x and y, x needs to be written as y. So this is the critical part. Okay. So when you restrict the domain of a function, make sure you write down the domain in the form of inequality, and make sure that you rewrite the form of inequality for x as an inequality for y. All right, now step 3. Let's see how this helps us in solving for y. So if you solve for y, what do you do? How do you get rid of the square? What do you get? What gets rid of the square? Square root, yeah. But whenever you put the square root, there's something extra you have to do. What do you have to do? Plus or minus, yes. You need a plus or minus, okay? And then y is 0 or greater. Now, as it is, this is not satisfactory because, like, for us, the positive ones are like the blue chickens, and the negative ones are like the red chickens prohibited. We prohibited the red chickens ever being fed into this function, right? So that was good. But now when you solve it, you not only get the positive ones, which are the blue chickens, but then the negative ones, which are the red chickens, right? So what should we do? Something's not right here. What should we do? Well, that's when you use this information. If we know that y is 0 or positive, these two combined means that y should be equal to what? Just square root of x. See, negative square root of x would be violating this condition, right? So the negative is now prohibited, and this is what you get, okay? Is that good? All right. So the answer is f inverse of x is equal to square root of x. Now, I had some fun making fun of people who couldn't draw the reflection over y equals to x, right? Last time, yeah. I was like going around and see who could get the reflection. Now, a moment ago, we learned that when you look at the graph of the inverse function, what is it? You're flipping over y equals to x because you're changing x and y, right? X and y are changed. So if you wanted to know the graph of y equals to square root of x, all you have to do is you have to flip this to the other side. What would be the resulting graph? Well, it's like a parabola opening up, but only half of it, right? If you flip the parabola opening up on the diagonal, what kind of parabola do you get? You get parabola opening to the, not down, to the right. That's what we had last time, right? So this is what you get. This thing would flip over the y equals to x. This is what we get, right? So, but because we only have this portion, we are only going to get that portion of the graph. So the graph of y equals to square root of x is going to be this graph. Okay? So you kind of understand a little bit more than before. Before, when I told you that you should know the graph of y equals to square root of x, I just said make a table and this is what you see. Now we know a bit more. We know that this is really 1/2 of a parabola where this side has been erased. That's what this graph is. We gain a little bit more understanding of what this is, right? Yeah. And then additionally, now what if we didn't erase this side and just drew the reflection? Then we would get the entire thing. Now, if you had the entire thing, would this pass the vertical line test? No. But then look, the horizontal line here, if you reflect over, it's going to be a vertical line passing through 9, right? So another way to understand the horizontal line test is that it's really the vertical line test applied to the reflection over y equals to x. So in other words, if you have a function and if you wanted to know if the inverse existed, what you do is just switch x and y, draw the graph, apply the vertical line test. That's same as applying the horizontal line test to the original graph. If it fails the vertical line test, we know it's not a function. So if it fails the horizontal line test, we know that the f inverse wouldn't be a function. Does that make sense? That's another way to understand why the horizontal line test makes sense.